so to get back to memory as a gross exaggeration, this is going to be very simplistic, okay? Like we said, each one of these will have like an Excel row or column of, I can't even do, of bytes, right? All the way down, and each one of these, let's just represent them like this, right? Let's just do that, and there's a billion of them. So let's pretend that the first byte here, its address is 0. The last one here is going to be, the last little byte here is going to be like address 1 billion, right? And each one they're all big columns. And so when you launch your computer, when you start your PC, you first redo. Your operating system allocates, certain areas to certain programs. So let's say like your Windows start, I think, is all the stuff that is in the beginning, the beginning addressable bytes, and then whatever, like Explorer is going to go from here to here. Games that you have, when you're using them, this is actually when you are using them. Of course, your Windows is going to be used, so it's going to use all of it. It's going to be stored right away. But then let's say you click on Visual Studio and your computer says, all right, Visual Studio is going to use all of these, all of this space. Then your program is also another program, and when you run this, the actual text is like your operating system will give you, let's say, somewhere here. Let's make it yellow. This is going to be like where your code lives. This is where it lives, and this is where it can use space to do things. Let's say, so basically, if we just look at this yellow square, it's going to be, and the red is going to be the big chip. So I'm talking about basically this. So from here to here, that's the big chip, and then within that, oops, sorry. This is the big chip, and then within that, you have your Visual Studio and, sorry, your program. These will actually hold the code that you wrote, right? This is gonna be just the gross exaggeration. It's not per byte, but anyways, there's some bytes that are going to be used by, they're going to be storing the actual text. You can do a copy paste line by line, all right? Gross exaggeration, and the empty space here is going to be used by whatever you declare inside your program. So right now we just did int x equals 8, meaning there's going to be a byte somewhere on runtime when you start the application, somewhere in here, and you're only allowed these guys a certain amount of free space to put your x equals 8 here. And whatever more code you write that needs to be loaded, because basically this is considered a load. X is just this spot somewhere, and on load I want to put an 8 into it, so I'm actually loading something into it. So when the program runs, it uses one of these free spots to put x equals 8. So you have to keep that in mind, because you have a limited amount of space, whichever space we're talking about here. It's called the stack. So whatever code you add here, depending on what you make it do. So let's say if you want to make an application that says, all right, I want to create, when you start, make a table of 10 that's going to hold tickets. So let's say a ticket is 1 byte, then on run, you're going to make sure that it's only using 10 of these guys. Okay, so now, to tie things all together,